Welcome back to Think Thrice Problem Solving. Today we're going to be solving a fun integral. So let's take a look at this one. So we have the integral of the square root of 4 times 4 plus x squared, all underneath the radical. And this one initially looks pretty easy, but it's going to end up being a little bit tricky. So if you'd like to solve this on your own, go ahead and try it out. Otherwise, we'll go ahead and work through it. So to start out here, I'm going to go ahead and pull the 4 out from under the radical. So we're going to get 2 times the integral of the square root of 4 plus x squared dx. And we should hopefully be kind of thinking some sort of trig substitution here. It's kind of jumping out at us. So we have the plus sign, so let's go ahead and try u equals 2 tangent, or sorry, x equals 2 tangent of theta, and dx is equal to 2 secant squared of theta, d theta. And let's go ahead and do that substitution. So when we do that, we're going to get 2 times the integral of square root of 4 plus 4 tangent squared of theta times 2 secant squared of theta d theta. And we can go ahead and pull out another 2 from inside of a radical, and we can move that other 2 out. So we can move this guy out here, take this 2's, move them out as well, and we're going to end up with 8 outside of our radical with the integral of the square root of tangent squared, 1 plus tangent squared. So remember that 1 plus tangent squared is equal to secant squared of theta. So that's the whole reason we do the trig substitution. So we're going to be left with just secant theta times secant squared of theta d theta, which is going to leave us with 8 times the integral of secant cubed of theta d theta. Okay, so this may or may not look better to us, but this isn't a common integral that we've seen and kind of worked on, so let's go ahead and look at this guy in a little bit more detail. So let's pull him down, and we're starting off our new integral. We have 8 times the integral of secant cubed of theta d theta. And we notice that we have secant theta times secant squared of theta, and secant squared of theta is the derivative of tangent theta. So let's try integration by parts here. So if I make u equal to secant of theta and dv equal to secant squared of theta, that gives me my du equals secant theta tangent theta d theta, and this gives me my v is equal to tangent theta. So let's rewrite this. So I have this expression here is going to be equal to secant theta tangent theta, 8 secant theta tangent theta, plus, or minus, sorry, 8 times the integral of v du, which is going to be secant theta times tangent theta, and that tangent theta is going to be squared because I'm multiplying v times du d theta. Okay, so now I have this secant theta times tangent squared of theta, which once again doesn't look great for me. But I notice that tangent of theta here is secant squared of theta minus 1. So what I can do, so let's note that. Let's note that tangent squared of theta is secant squared of theta minus 1. So if I look at this, this then becomes 8 secant theta tangent theta minus 8 integral of secant theta times secant squared of theta minus 1, which is then 8 secant theta tangent theta minus 8 integral of secant cubed of theta d theta minus 8 integral of secant theta d theta. And what I notice here is I have on the right side the same thing that I started out with on the oh, and sorry, I missed. So I have a minus sign here and a minus sign here. So this guy's a plus sign. Okay. But what we notice is we have this, and this is the same format as what we started with on the left. So let's go ahead and move that over. And we now can see that we're going to get 16 times integral of secant cubed theta d theta is equal to, now I'm going to take these two guys, 8 secant theta tangent theta plus 8 integral of secant theta d theta. Okay. And most of us don't have the integral of secant theta just memorized. But there's a little bit of a trick we can use. So what we can do here is we can go ahead and, so we'll keep that 8 secant theta. Actually, let's go ahead and just focus on the integral. So let's focus on this integral right here. So the integral of secant theta d theta. So we notice that what we could do is if I do a little bit of a trick, so let's multiply the top and the bottom by secant theta plus tangent theta. And what I notice here is the derivative of secant theta is secant squared of theta, which is these two guys multiplied by each other. And the derivative of tangent theta is secant theta times tangent theta. So if I make u equal to secant theta plus tangent theta, then du is going to be secant squared of theta plus secant theta tangent theta, which d theta, which is exactly what I have in the top. So this purple integral is going to be the natural log of secant theta plus tangent theta. So if I look at my original form up here, now if I combine my terms, I'm going to get 16 secant cubed of theta is equal to 8 secant theta tangent theta plus the natural log of secant theta plus tangent theta. And now we're looking pretty darn good. So, once again, so we dropped that 8. So that 8 should be out here. And then he follows us down, come here. So this will be 8 as well over here. So now if I divide out that 16, I now get, or if I divide out the 2, because what we were originally solving was 8, so my original problem I'm solving is 8 secant cubed of theta is equal to 8 secant theta tangent theta plus 4 secant theta tangent theta plus 4 natural log of secant theta plus tangent theta. And now we're looking pretty darn good. So we remember that our original substitution, if we go back up to the top, we had a substitution where we put x equals 2 tangent of theta. So our original was x equals 2 tangent of theta. So that means that tangent of theta is equal to x over 2. And then let's go ahead and look at our unit circle. So if we pull out the unit circle, so if we have x and 2, then this side over here is going to be the square root of 4 plus x squared. So that means that secant of theta is going to be the square root of x squared plus 4 divided by 2. So now let's go ahead and make our substitutions back. And we get that our answer is going to be 4 times the square root of x squared plus 4 over 2 times x over 2 plus 4 natural log of secant of theta, so square root of x squared plus 4 over 2, plus tangent of theta, which is x over 2, plus some integrating constant. And we have a few things that cancel, so that 4 is going to cancel out with these two 2's. And we're ultimately going to be left with our final answer, is x times the square root of x squared plus 4 times the natural log of x plus the square root of x squared plus 4 all over 2. And that is our final answer. So it turns out that we had to do a little bit more work with trig substitution than we may have originally thought, but we are able to arrive at our final solution. If you enjoyed that problem, feel free to like and subscribe. If you have your own problem, whether it's calculus or some other problem that you'd like to see solved, please submit it, and I'll go ahead and work through it and post a new video. And as you're working through your own problems, always remember, think thrice.